For this study help, we are looking at the subject matter of molecular geometry. So let's take a look at the question that you missed and explain all four of the different possibilities and why they're correct or incorrect. So here is the question that you were looking at. We want to determine what the molecular geometry of this molecule, which is CH4 methane. If we draw out the Lewis structure, this is what the Lewis structure of methane looks like. And our possibilities were a tetrahedral, a bent geometry, trigonal pyramidal geometry, or linear. The correct answer to this question was a tetrahedral. So it was not bent, it was not trigonal pyramidal, and it was not linear. So let's go through our step-by-step and see how to answer this question. So there's 3 steps involved in this, and at the end of this we should be able to determine why this is a tetrahedral instead of our other 3 choices. So step 1 tells us to draw the Lewis dot structure. So if you've forgotten how to draw the Lewis dot structure, just go ahead and jump back to the step-by-steps that explain how to draw the Lewis dot structure, and then you can come back on and continue. But we're going to assume that you know how to draw the Lewis dot structure. Then next we're going to count the number of bonds and lone pair to the central atom. And finally we're going to determine the molecular geometry based on a table. And you may need to memorize this table. It's pretty short for possibilities of molecular geometries when we're just looking at some basic molecular geometries, or it might just make sense once you see it. So kind of whichever one you want to do. So let's go through our step-by-step. Step 1, draw the Lewis structure. So here's our 4 possibilities. We've got carbon dioxide, and here is the Lewis dot structure of carbon dioxide. The next one is CH4, or methane. This is the Lewis dot structure for methane. And for ammonia, which is NH3, here's the Lewis dot structure for ammonia. And finally for water, H2O, here is the Lewis dot structure for that molecule. Okay. You're going to notice that in the carbon dioxide we have a couple of double bonds. The rest of them have either single bonds or lone pairs. And when we're determining molecular geometry, we don't have to count those double bonds or triple bonds. We just count them one time. So when we're trying to determine the molecular geometry based on the table, just remember we only count those double bonds or triple bonds once. Okay, so step 1, we do the Lewis dot structures. Step 2, we're going to count the number of bonds and lone pairs to the central atom. The central atom is typically the one in the middle of the structure. It's the one that's really needy for electrons. So it's the least electronegative atom, and it's typically in the center. So first let's look at carbon dioxide. In that case, carbon is the central atom, and remember we don't count double bonds or triple bonds except for once. So we're going to say that bonds to the central atom is 2, and we're going to say lone pair on the central atom is 0. So the lone pair is represented as those 2 dots together. So you'll see oxygen has some lone pairs on them, but the central atom carbon does not have any lone pairs. So for our first analysis, we're going to say carbon dioxide has 2 bonds to the central atom and 0 lone pairs on the central atom. All right, let's look at methane. Carbon is the central atom in methane, and so in this structure, and this is why you have to draw the Lewis structure out, because you can't do this in your head. Okay, you have to draw this so you can determine how many bonds and how many lone pair you have. So in this structure, we have 4 bonds. All those hydrogens have a single bond to carbon. And again, there are no lone pairs represented on that central atom. So so methane is going to have 4 bonds to the central atom and 0 lone pair. And let's take a look at our next possibility, which is ammonia, or NH3. Nitrogen is the central atom that we're going to take a look at. And in this example, there is a lone pair on that central atom. So nitrogen has 3 single bonds to hydrogen bonded to it, and 1 lone pair. So 3 bonds to the central atom and 1 lone pair on nitrogen. And finally, let's take a look at water. For H2O, oxygen is the central atom on that molecule, and it has 2 single bonds to hydrogen, and to itself it has 2 sets of lone pairs. So for oxygen, we're going to have 2 bonds to the central atom and 2 lone pair. Okay, so now we've made our table, and now we're going to turn this table into a geometry. So that's step 3. Step 3 is to determine the geometry based on the table. So let's pull up our table again, and let's see what each of these mean. So for any molecule, when you have 2 bonds to the central atom and 0 lone pair, you have a linear geometry. Why do you have this geometry? Well, what the atoms will try to do is they'll try to get as far away from each other as they can, but they're still tethered to the central atom, which is carbon. And so as these oxygens try to get as far away from each other as they possibly can, because their electrons are repulsing each other, that forms a linear geometry. Okay, so that would be the first determination. Let's take a look at CH4. We said that there were 4 bonds to the central atom, no lone pairs to the central atom. Whenever you have this situation, you have a tetrahedral. So in this case, the reasoning behind this is because we have those 4 hydrogens bonded to that carbon. They want to try to get away from each other in 3D space as far as they possibly can. And to do that, they would form a tetrahedral geometry. So that is why we see that, and that was our correct answer when we were looking at the question. Let's continue to look at ammonia. So whenever you have a molecule that has 3 bonds to the central atom and 1 lone pair on the central atom, you're going to get something called the trigonal pyramid. And why you have this is you've got those 3 atoms bonded to nitrogen, and they're still trying to get away from each other as much as they can, but that lone pair that's also tethered to that nitrogen is really a big hog as far as producing a negative electron cloud, and so that's why it pushes down on those other 3 hydrogens. And when you're looking at geometry, you don't really look at the lone pair once you're just considering geometry. So if you just look at that nitrogen and the 3 hydrogens, they form kind of a pyramid. And the pyramid is a triangle, and that's where we get that word trigonal pyramid. Or if you can't really see that very well, you can always just say, well, there's 3 bonds to the central atom, 1 lone pair on the central atom, so I know because I've memorized it that that's a trigonal pyramid. And finally, we've got water, H2O. In this circumstance, we have 2 bonds to the central atom. We have 2 lone pair bonded to the central atom. And when we have a situation like that, you get a bent geometry. And so in this bent geometry, you've got these 2 hydrogens. They're tethered to the oxygen, trying to get away from each other, but you also have those 2 lone pair up there on top pushing down on those hydrogens. So those 2 lone pair take up all the room, and the two hydrogens are pushed together pretty closely, and that's where you've got this bent geometry. So again, when we're looking at geometry, we're not really looking at those lone pairs of electrons. We're just looking at that angle between oxygen and hydrogen. So when you look at the hydrogen, oxygen, hydrogen, that represents something that's a bent geometry. Or if that's hard to see, again, you can memorize it. Anytime you've got two bonds to the central atom, two bonds to the lone, or two lone pair on the central atom, you'll have a bent geometry. Okay, so that is our step-by-step. Those are the steps that we took to be able to determine which one was the right answer. So just again, you might have to memorize this table. This is the very simple table, but if you count up your atoms bonded to the central atom, you count up your lone pair of electrons, you're always going to get this answer. And those are the different possibilities you could have. So what we did was we followed our step-by-step, and for each of the subject matter, it will be in this format. Well, you'll have 3 to 6 steps that you follow. And then there's a worksheet that you can go to now if you think you want more practice. There's 8 to 10 questions and then the correct answer on the worksheet. And then you are ready to try another question and see if you get it right this time. So good job going through the format and keep trying. You're going to do great.